Hi class, today we're going to talk about friction. Let's go ahead and define it. Friction is the opposition to motion. So it's a force that slows something down or it prevents an object from moving. In case you guys don't know this, every surface has some sort of roughness to it. No surface is perfectly smooth. So if you were to zoom in on a surface super close, every surface has some sort of bumpiness to it. And when you have two surfaces interacting with each other, it's those little bumps that cause them to either slow down or to prevent movement in the first place. Now we've got a symbol for friction. You guys know this. It's F sub F. Now because surfaces can move really easily against each other, or they could be really rough, like sandpaper, we can't just say really rough, really smooth. In physics, we got to put a number to it. We got to be really exact. So we're going to have like a variable here. Okay, so here's our variable to describe the roughness or smoothness of different surfaces. And that's going to be this weird Greek symbol, which we call mu, which is like saying the words me and you really fast. So it's mu, and that is called the coefficient of friction. It sounds very fancy, but it just means like smoothness or roughness. And it's going to be a number, okay? So it's going to range from about 0 to about 2, which means it's like a ranking system. The higher the number, the higher the friction or the roughness of the surface. So, if you have a hockey puck on ice, those are really smooth surfaces, the ice and the hockey puck, and you might have a coefficient of friction of 0.1 or maybe even a little bit less. But if you're, pushing, some rough surface on sandpaper, you might have a coefficient of friction of maybe like 1.4, 1.5, 1.6. There's two types of friction. One is static friction, and this is friction that prevents movement. Which is like grip, okay? Your shoes grip onto the floor. A book is gripping onto your table if the table's slanted and doesn't move. So it's friction that prevents movement. And then there's kinetic friction, which is friction from sliding. So you sliding your desk across the floor, you pushing your desk across your table, you pushing your calculator across your desk. Those are all kinetic frictions. We're going to focus on kinetic frictions. We're not going to do any static frictions, at least not yet. We're not going to do these problems, we're going to have to remember how to do f of g. So to calculate out f of g, it's really easy. F of g equals mass times 9.8. That's going to be a given for all our problems. And if I just said determine the force of gravity on a 60 kilogram student, you would just do the 60 kilograms times 9.8, and you would get 588 newtons. So that's just a reminder of how to get f of g. All right, I'm going to just go ahead and give you the force of friction equation. Sometimes we might do it with a lab, but today I'm just going to go ahead and give it to you. So to determine the amount of friction on an object, it's going to depend mainly on two things. Number one is that mu, which is how smooth the surface is. It also depends on how heavy an object is, which we're actually going to use Fn, which I'll get into more detail later. So it turns out Fn and Fg in all our problems are going to be the same. So it's pretty much just your coefficient of friction times your F of G or your weight. Now, in all of our problems in this worksheet, what's going to happen is something is going to be pushed. So let's just say over here, there's an object that's being pushed, and it's got friction because it's on a surface. Okay, and then the normal force is pushing up on it, and gravity is pushing down. What makes these problems super easy today is the fact that our acceleration is going to be 0. All these problems are going to be at a constant speed. So what makes this really great when we have an acceleration that is equal to 0, so when things are moving at a constant speed, what you can see here is that our Fn is going to equal our Fg. So this right here, our Fn is the same in all these problems as F of G. And also, our applied force is going to equal our friction force because the acceleration is 0. Now, granted, at one point it was accelerated to get the object moving in these problems, but we're only looking at it as the things are moving at a constant speed, and therefore the applied force is the friction force. So that makes these problems super simple, super fast, and you'll be able to fly through these really quickly. I'm going to go ahead and I'm going to do the first 4 problems, and then your assignment is to finish up the rest of these yourself. So first problem says the coefficient of friction between road and the rubber tires is 0.8, and it has the car has a weight of 13,320 newtons. How much friction will the car experience while driving at a constant speed, or probably even more likely just slamming on their brakes and sliding to a stop? So our friction formula is just Ff equals mu times Fn. We want to know how much friction there is, so we multiply the coefficient of friction, 0.8. We multiply it by Fn, and Fn is basically the same as Fg. Okay, so this is Fg. And since this is already in newtons right here, okay, it has a weight, we can just plug the 13,320 newtons right in. We don't have to multiply it by 9.8 because the problem already gives us that weight in newtons. So 13,320 times 0.8 is 10,656 newtons, which makes sense because it's a car. You're going to have a high amount of newtons on the car. Moving on, number 2. The coefficient of friction between a book and a table is 0.21. The book has a mass of 2 kilograms. How much friction will it experience when it's pulled across at a constant speed? Okay, so again, friction formula is mu times Fn. Our coefficient of friction is 0.21. Our Fn is, remember, the same thing as Fg because the acceleration is 0 in all these problems and they're not being lifted off the ground. So, and this is mass, that's kilograms. So I'm going to have to do 2 times 9.8 to put that into newtons and to get Fn, which again is the same thing as Fg. So 0.21 times 2 times 9.8. And we get 4.1 newtons, which isn't a lot of newtons, but that makes sense because we're pushing a book, which isn't very heavy. All right, 2 more. So a friction force of 4 newtons acts on a wood block as it's pulled across a table. The wood block has a weight of 12 newtons. What is the coefficient of friction between the table and the wood block? Okay, so again, our friction formula. And we know the friction force, so it's 4 newtons. We don't know the coefficient, so that's mu. And we're trying to, let's see, the Fn, this is already a weight. That's your Fn. So this is 12. So we would divide both sides by 12, and mu would equal 0.333. Oh, and I forgot to say that this has no units. It's like saying how much do you love school on a scale of 1 to 10. There's no unit at the end, like meters or kilograms or anything like that. It's just a number from 0 to 2. Okay, and since we ended up with 0 to 2, and 0.33 is pretty common for tables and floors and other fairly smooth objects like blocks, so that makes sense. Last problem. It says you're pulling your sibling across the snow in a sled. There's 30 newtons of friction as your sibling travels at a constant speed across the snow. Your sibling has a mass of 40 kilograms. What's the coefficient of friction between the snow and the sled? So just like before, I'll use my friction formula. And we know that there's 30 newtons of force, or friction, I should say. We don't know the coefficient of friction, and we're given a mass of 40 kilograms. So we're going to have to do 40 times 9.8 to get the weight, which again is, in all our problems today, the same as the normal force. So then you would divide both sides by whatever 40 times 9.8 is. So 30 divided by parentheses, 40 times 9.8, and close my parentheses, and I get 0.076. And you might ask yourself, is that good? And the answer is yeah, and the reason why that's good is because it's in between 0 and 2, and snow and sleds are, very little friction between a snow and a sled, so it should be a really low number. It should be closer to 0. So that's how you do these problems. The remaining problems are for your homework. Good luck. Thank you very much.